Okay, so imagine this, right? You're spending tons of time, hours on end, learning about shellcode, learning about DLLs, learning about process injection, whether it be into your local process or into another remote process on the machine. And you finally get to the point where you're writing your own code and generating shellcode from MSF Venom. For example, here we're generating a calc.exe shellcode. And you come to the point where it's finally time to run it. You hit play to compile it, and boom, you're hit with this message. Threats found. Microsoft Defender has blocked your malware. Well, what are you going to do now? Now you're frustrated, you don't know what to do. But there are tons of ways to solve this problem. And in this video, I'm going to show you exactly what you have to do to get your malware or your shellcode past any signature-based antivirus detection. So this video specifically is going to focus on using IP addresses to obfuscate your shellcode. The reason that this works is because an unsigned char is a value up to 255, which is the same as an IP address, which means we can convert this shellcode into what looks like IP addresses essentially, and that masks the image of the shellcode itself. Now you could take this a step further and start off by encrypting or base64 encoding the shellcode, and then follow up with some other form of obfuscation like IPv4 encoding as well. But in this video, we're just going to use IPv4 encoding to obfuscate this shellcode and hopefully bypass signature-based detection. So to do that, it's going to take two components. The first component is going to be the encoder. So that's where we'll put our shellcode in, which is this raw shellcode straight out of MSF Venom. We'll put this in, we'll encode it into IP addresses, and then we'll bring it back over and programmatically decode and inject that shellcode. Before I get started though, I must say, or give a quick disclaimer, the content in this video is for educational purposes only. Don't use it for illegal activities. Only do process injection, malware development, etc. on systems that you have permission to do it on or own. I'm not to be held responsible for any stupid things that you might do with what you learn in these videos. Okay, so moving forward now, let's make our first component. So our first component is going to be the encoder. I have two projects here in my solution. One's the inject, one's encode. The inject I went ahead and created. This is the code straight from our previous video about shellcode injection. And the reason why it would run before is because I had my development path whitelisted. For this video, I removed the whitelist temporarily. We're going to have to turn it back on for a second, just so that we can get our decoder to, or our encoder to encode the shellcode. And then we'll flip it back on to show or see if it indeed does bypass Defender. So what we want to do first is hop over to encode. We can make a new item. We'll just call this encode. And I'm just going to paste some of the code here. That way we can move a little faster than we usually do. And so what we want to do, I'll start off with our function to encode IP addresses. So what this is, it returns a vector of strings, and it takes, as the name says, bytes, and converts them to an IP address. So we'll pass it our unsigned char of bytes and the length of those bytes. But first, just to get rid of these errors, let's include vector and include a stream Okay. Okay, so what this does is it has a vector of strings called IP addresses. Because this is where we will push our IP addresses after we convert. So we're casting our bytes to ints. We're adding the decimal for each octet, and it will create an IP address. So then we'll return our vector of IP address strings, and after that, we want to format it so that it makes sense to us, and so that we can just paste it directly into into our injector, essentially. So let's start off by just pasting in our shellcode from before. So here's our shellcode. MSF Venom just executes calc, as we said before. We'll paste this here. And for the size, we'll do buff length is the size of buff -1, just to trim off any null terminator character at the end. There we go. And then we will call our function bytes to IP address. So just do auto IP addresses, bytes to IP addresses, and then we will pass in our buff and buff length. And then what we want to do is we want to print this in a way that makes sense, that we can read in the injector without having to like hand type everything. So what we'll do is just use printf, and we want to print this into a format that is C++ compatible. So I'm going to put them into a vector of strings, and we'll call it IP addresses, and make a new line. Then what we want to do is we just want to loop over our IP addresses, and we want to print each one as a vector item in our vector string that we're creating. So we'll do IP addresses, and then we'll print f. For this, we want to format this as a string. Oh, sorry, let's fix this. So then we'll do %s, maybe. Okay. Then another parentheses around it, a comma, and then a new line. And then we just pass IP. And then at the end of that, we want to close our vector of strings with a curly brace. Oh, maybe with a curly brace. Okay, so ideally this will print a well-formatted vector of strings that we can just paste over into our injector. So let's give that a try. So first thing we want to do is switch our startup project. We don't have to do it this way, but it's just quicker for me. We can run it and see we're still getting triggered on AV. So I'm going to just jump over to my antivirus really quick on the other screen here, and I will just flip off real-time protection. Okay, so now let's compile and run again and see if we trigger AV. Nope. Okay, but we are printing some weird strings out here. So let's fix that real quick. Okay, that should fix it. We'll run again and awesome. So now we have a vector list of strings that appear to be IP addresses, but this is actually our shellcode. So let's copy this. We can take that and bring it over to our inject.cpp. We'll delete our initial shellcode and let's import some of the requirements here, and then we'll see if we can decode it and execute. So we'll do vector. Let's add a function here. I'm just gonna paste the function in. This function will convert our IP addresses back to bytes. So we'll get a vector of unsigned chars back out. We're passing in a vector of strings, which is our IP addresses. We'll loop over it, each one of them. We will cast back to an unsigned char and just return our byte array. So need to include a stream. There we go. Now we will pop down here to the bottom. Let's add our semicolon. And what we want to do is we want to convert these IP addresses back to a byte array, get the size of that array, and then we can proceed to inject like we normally would. So let's do auto byte array is IP addresses. What was it? IP addresses to bytes. 2 bytes. And we can pass in IP addresses. Then we will, we need to get the size of that, so we'll do size t by variable size is byte array. So do byte array dot size. And then we want to create an unsigned char array that we can use, that we can move these bytes into and inject. So to do that, we will just do unsigned char byte variable is a new unsigned char. That's the size of our byte array. So byte array dot size, or we could have passed in our byte variable size. Either one's fine. And now we want to move our bytes from the byte array into our new unsigned char array. So to do that, we will just loop over it. So we'll go size t I equals 0 while I is less than, we'll just say byte var size. And then we'll do byte variable I is equal to byte array I. Okay. And that will copy everything over to our new byte variable. Okay, so now all we have to do is come down to our existing injection allocation and memory copy, adjust these variable names, and we should be good to go. So for the size, we're just going to pass this our byte variable size that we created earlier. And here for our buffer is actually a byte variable now. And then again here we can just grab this variable, byte variable size, and assuming we put everything where it needs to be, we should be able to run this and we'll get a calc. Let's first switch this to the startup project, run this, and we do. Okay, so now the moment of truth. Let's move back over, turn on real-time protection, and let's run this again. Awesome. So we have effectively bypassed signature-based detection. In the future, I'm sure this won't work. That's just how this works as a game of cat and mouse. But the true beauty of this is that you can come up with your own ideas for encoding. You can come up with your own custom encoding, and always have a new way to encode and obfuscate your shellcode. In the future videos, we'll look at some other ways to obfuscate the shellcode and just work through them one by one. I hope you enjoyed this content. If you did, please make sure to like, comment, subscribe. It really helps me out. And I will see you guys next time.